All right, here are the notes for lessons 2-5. All right, we'll start with complementary and supplementary angles, and we've seen these in the past. These are complementary angles, or two angles that add up to 90, so as the picture shows. We'll just go angle 1 plus angle 2 in this picture equals 90 degrees. We would call angle 1 and angle 2 complementary angles. They don't have to be equal. Supplementary angles are like angles 3 and angle 4 here. They would add up to a straight line 180 degrees. Adjacent angles. Here's a kind of a new word. Adjacent just means next to. So I'm not going to really say that angle 3 and angle 4 are equal. They don't really add up to anything, but they are just next to each other. So every once in a while, you'll see word problems that say adjacent angles. All right angles are congruent, which kind of makes sense. A 90-degree angle is equal to another 90-degree angle. So if someone says angle X is 90 degrees and angle Y is 90 degrees, then these two angles are equal to each other. Kind of common sense. Moving down to the second row here, the vertical angle theorem. Vertical angles, whenever you have crisscrossing lines, vertical angles are like opposite each other, so like 1 and 2, 3 and 4. Those are vertical angles. But now we actually have a theorem based on it. Vertical angles are congruent. So in this picture, angle 1 is flat out equal to angle 2. Angle 3 would also be equal to angle 4. If I took a protractor and actually measured angle 1 and angle 2, they have to be congruent. There's no way they would not be. The next two are congruent complement theorem, congruent supplement theorem. Obviously, complement means two angles that add up to 90, supplement two angles that add up to 180. But let's read this and then we'll draw a picture on what it's actually saying. If two angles are complementary to the same angle, then those two angles are congruent. This is the congruent complement theory. So that's saying a lot here. Let's try to demonstrate this with pictures here. I'm going to first start off with a complementary angle here. I'll say angle 1 and angle 2 here, and also angle 3 and angle 2 here. So let's now reread this problem. If two angles, like angle 1 and angle 3, are complementary to the same angle in this case is angle 2, then those two angles are congruent. So then angle 1 is equal to angle 3. All right? And kind of the same idea with this next one. If two angles are supplementary to the same angle, then those two angles are congruent. And so we will try to draw this scenario. If you see something where angle 1 and angle 2 here form a straight line, supplementary, and also angle 3 and angle 2 are supplementary. If this occurs, then angle 1 must be equal to angle 3. If two angles are supplementary to the same angle, which happens to be angle 2, then these two angles must be equal to each other. I don't know the degree amount, but they would be equal to each other. Congruent supplement, congruent complement. Okay, we are going to try this word problem here. Excuse me, not a word problem, but two-column proof. Again, we've got two columns here. There are statements, there are reasons, and we're going to start off with this. 4x minus 101 is equal to 2x plus 5. Now, a lot of times when we start these two-column proofs, it always seems like step 1 is given, step 2, step 3, but step 1 always seems to be given. There really isn't anything given here. Actually, the picture is given itself, but better than just saying given, why would this 4x minus 101, why would this angle here be equal to 2x plus 3, equal to this angle here? Well, that's a new theorem that we just mentioned. Those are vertical angles, and vertical angles are congruent. It is called the vertical angle theorem. So the reason why I can say this pink angle is equal to this pink angle, we're going to go with vertical angle theorem, because those are vertical angles. Okay? And then hopefully the rest of this is pretty easy. Let's look at the calculations here. What happened to the 101? It looked like it got added to the other side. You don't have to put the add 101, but we definitely want to write addition property, abbreviating property and theorem there. Then somehow the 4x turns into 2x. This 2x is gone, so it looks like they minused it over, so we'll go with subtraction property. And then finally, it looks like divided by 2 division property. Okay, but the key with this two-column proof is the first step here. You're going to look at the picture here and decide, why would this portion be equal to this portion? Well, sometimes they're vertical angles. Sometimes maybe you might see something like this. Who knows? This might have been 4x minus 101, and this might have been the 2x plus 3. This is a totally different problem here, but they might have put a right angle there and a right angle there, and then you would say, well, why would this angle here be equal to this angle here? Instead of vertical angles, we would say all right angles are equal. And that could be something in the future. All right angles are congruent, are equal.